hear you singing out the song one more time, I swear to God. So annoying.
It's also annoying when you say things like that. Okay, so we're on science, Earth's four spheres sort.
Who's singing that?
I'm going to play 3 videos. Mohammed, do you need to take a break?
I literally just got back from my break. How are you going to tell me if I want a break?
Because you're annoyed and yelling at the class.
I'm yelling at the person who's singing that dumb song.
But you don't know who's singing it, so you're yelling at the class.
It's probably him.
Pleasure.
Bro, I'm not even singing anything. I can hear you.
Okay, focus. Ready? So click on this class kick and log in while I play the 3 videos, okay? So first we're going to start with, what are Earth's systems? That's super quiet. Let me connect my microphone.
Upland deforestation impact water quality downstream. How do melting glaciers in the Arctic affect sea level in Florida? The field of Earth system science can help answer these complicated global questions. But what are Earth systems, and why are they so important? The Earth is a large, complex planet made up of many different systems that interact in countless ways. Scientists divide our complicated Earth up into simpler processes so that they can be studied more easily, and this concept is called Earth systems. Though separating our Earth's processes can help us understand them, in reality, these systems are interconnected with one another. The four main systems, or spheres, are air, land, water, and light. The air system is called the atmosphere. It contains gases, regulates temperature, and blocks radiation, houses weather and wind, and drives climate systems on Earth. The land system is called the geosphere. Within the geosphere are rocks, soil, continents, fossils, and tectonic plates. The geosphere is composed of features at the Earth's surface as well as everything below, including the Earth's core. The water system is called the hydrosphere. It includes all the salty and fresh water across the globe and how it all moves through the water cycle. The biosphere is made up of all life on Earth. It includes plants, animals, fungi, bacteria, and all the interactions between them, like symbiosis and predation. In addition to those main 4, other Earth systems include the anthroposphere, human interactions, the magnetosphere, everything to do with the Earth's magnetic field, and the exosphere, everything outside our planet, like the solar system and beyond. Earth system science is the study of all of these different spheres and how they interact. For a long time, scientists had studied things like air, water, land, and light separately, but Earth system scientists combine these different areas of study to understand Earth as a whole. Just like how each ingredient of a pizza is tasty on its own, when combined, they offer a whole new flavor perspective. Earth system science draws upon the fields of ecology, biology, geology or earth science, meteorology, chemistry, oceanography, physics, and more to make sense of how our planet's different systems work together. That's why this type of science is often called interdisciplinary, made up of many different scientific disciplines. Earth system science is important because it helps us understand how the Earth was made, what it's like now, and how it will change in the future. Finally, studying how humans affect one Earth system and how that in turn affects others can help us make informed decisions about the policies and actions needed to preserve the health of our planet. Let's take a look at what an Earth system scientist might think about when studying a Florida habitat. Consider a classic type of Florida ecosystem, mangrove swamp wetland. Using energy from the sun, mangroves and other plants produce oxygen that animals like fish, snails, birds, gators, and more must breathe in order to survive. The waste produced by these animals, along with any decomposing individuals that might die, introduce the nutrients into the ecosystem that help the mangroves and other plants grow. The sandy bottom of the swamp allows mangrove seeds to take root, and as the mangroves grow, they help trap and pile up additional sand around them. Fresh water flowing from the land and salt water moved by nearshore wind of the currents and tidal action transport additional sand and nutrients into the swamp. Even through the simplified view, you can see the Earth system interacting to make the wetland function. Human activities can have a big impact on all of Earth's systems. The burning of fossil fuels releases pollutants into the atmosphere, which can harm humans and other animals in the biosphere. Construction can increase erosion of the geosphere, and the resulting sediment can get dumped into waterways where it affects the water quality within the hydrosphere. Fortunately, by understanding how Earth systems interact, humans can have positive impacts on the planet too. That's what the Thomson Earth Systems Institute, or TESI, is all about. Founded in 2018, TESI's mission is to advance communication and education of Earth system science in a way that inspires Floridians to be effective stewards of the planet. Florida is on the front lines of massive Earth systems changes that are threatening our environment, our economy, and our way of life. Now more than ever, science-based information needs to be communicated in a way that resonates with all Floridians, so they can make informed decisions about our natural resources and our future on Earth. Visit our website or follow us on social media to learn more about how these Earth system changes are affecting Florida and what you can do about it.
Okay, so that was the first one. There's one more. So what on earth?
You know, some things just make sense together. Like peanut butter and jelly, or burgers and fries, or water and dirt? Okay, let me explain that last one. So we've already talked about how the Earth is divided into 4 spheres. That's the hydrosphere, the geosphere, the biosphere, and the atmosphere. Well, today I want to focus on just the first 2 of these spheres. The hydrosphere, which includes all the water on the planet, and the geosphere, which is simply the solid Earth. The hydrosphere and the geosphere are both equally important and different spheres of our planet. But do they interact with each other? And if so, how? Well, let's have a little refresher on what exactly both of these spheres are separately before we figure out how they interact together. You'll remember that geo means ground, so what we call the geosphere includes all the rocks, minerals, and ground found on and inside the Earth. This means every single pebble in the mountains, every grain of sand in the deserts, the entire ocean floor, and even the continents we live on are part of the geosphere. If it looks like solid ground, it's part of the geosphere. The geosphere includes the surface of the Earth, which we're on now, but it even extends down to the planet's core below us. Now, the hydrosphere is also found on the Earth's surface, and just below it too. But the hydrosphere also extends up into the atmosphere. Hydro means water, so the hydrosphere is made of all the water on Earth. And I do mean all of the water, like ponds, rivers, lakes, streams, oceans, glaciers on the Earth's surface, but also the moisture in the air, like rain, hail, and snow. That's all part of the hydrosphere too. So the geosphere and the hydrosphere are separate systems, but if we think of Earth as one giant system or a group of systems working nicely together, then the geosphere and the hydrosphere are 2 parts that work together to support life, like you and me, on the planet. How do these 2 spheres work together, though? Let's take a look at a model to find out. Since the geosphere is the ground, let's start by laying down some of that. And let's throw in some mountains, too. Now we'll need some water. Let's have a river winding through the land about here. How about a lake? And just for the heck of it, let's throw some rain over here. Okay, so you can see in this model some elements of the geosphere, right? That would be the ground and the mountains. You can also see elements of the hydrosphere. Say hi to the river, lake, and raindrops. But so what? Both spheres are there, but they're not really doing anything together, right? Wrong. Look closer. See that riverbed under the river? How about the bottom of the lake? Those things are part of the geosphere. They're parts of the geosphere that are supporting and surrounding parts of the hydrosphere. And check out the rain over the mountains. The rain, which is part of the hydrosphere, is falling on and running down the mountains, which is part of the geosphere. And this is just a really small example of the 2 spheres interacting. Every day, all over the earth, water is moving over landforms, from waterfalls flowing down mountains to ocean waves crashing on sandy shores. Water rests in lake beds or ocean floors, in river valleys, and even in the soil in your backyard, all of which are part of the geosphere. So on a basic level, the geosphere really provides a home for the hydrosphere, which I think is kind of sweet. But that's just me.
Conclusion.
So now you know a little bit about how the geosphere and the hydrosphere are connected. To find out how they can actually affect and even change each other, check out our next episode.
Okay.
This is Earth, home to 7 billion plus people, 7 continents, and all kinds of amazing plants and animals. This is what Earth has looked like for a long time, and will probably continue to look like for a long time.
Hold on. We have some not English subtitles.
That's Arabic, I think. Spanish.
It looks Arabic.
Spanish. That's Spanish, but in cursive.
No, it is not.
That's Arabic. That's Arabic. Yeah, it says Arabic right there. Put it in Spanish. It says Arabic. Arabic. Yay! Bro, why is it spitting?
Okay.
I'm gonna read it in Spanish.
Inside your head, please.
7 billion plus people, 7 continents, and all kinds of amazing plants and animals. This is what Earth has looked like for a long time, and will probably continue to look like for a long time, right? Yes. And no, sure, this is what Earth looks like from space. But even though it looks pretty much the same from whenever we view it from afar, once you zoom in on it, you can see it's always changing. On a small scale, things like moving water shape the Earth's landforms, the natural features of the Earth's surface. On a bigger scale, the gradual shifting of the Earth's crust is slowly moving even bigger things, like the oceans and the continents. So one day, our planet will look different, maybe a lot different from how it looks now. So how exactly does water shape Earth's landforms? Or to bring it back to the spheres we've been talking about, how does the hydrosphere affect the geosphere? To understand that, we need to discuss weathering. I'm not talking about the weather, like if it happens to be sunny or cold or foggy outside your window right now. I'm talking about weathering, the process that takes place as rocks and other parts of the geosphere are broken down into smaller pieces. Weathering can be caused by water, air, chemicals, plants, or even animals, including us. And there are 2 types of weathering you need to know about: mechanical weathering and chemical weathering. Mechanical weathering is the process of breaking big rocks into little ones. Frost, ice, the roots of plants, running water, or heat from the sun can all cause mechanical weathering. Chemical weathering involves the changes that some substances can cause in the surface of the rock that make it change shape or color. Things like carbon dioxide, oxygen, and acids can all cause chemical weathering. And when rocks have been weathered and all broken down and are later moved by natural forces like wind, water, or ice, that's called erosion. Weathering and erosion sound pretty similar, right? Well, yeah. But not exactly. Think of weathering as the hammer that breaks down the rocks. Erosion is the process that carries those rock fragments away, or put in a way we're all familiar with. Weathering helps make a mess, and erosion helps clean it up. Let's take a trip to the beach to see what part the hydrosphere plays in weathering and erosion. This is a picture taken from space of the coastline of Massachusetts in the northeastern United States. It's part of a landform called Cape Cod, and the picture shows what the beaches and islands around it looked like in 1984. Now look at this photo from 2014. What's different? There are actually more islands in 2014 than there were before. Back in 1984, that long strip of land was North Beach. Now, that strip of land has been chopped up into separate islands. The top part is North Beach, the middle area broke off into North Beach Island, and the bottom part is now called South Beach. So, how did that happen? Well, moving water is a major cause of erosion, and there's a lot of moving water in the Atlantic Ocean. The intense energy of ocean waves crashing on shore causes pieces of the rocky, sandy coastline to break into smaller pieces, or to weather over time. Then, natural forces like major storms and rising sea levels then move or erode these smaller pieces. Day to day, you might not notice any dramatic changes, but over the course of 30 years, well, as these pictures show, coastlines can change a lot. So, what can we take away from this? Well, we saw that water can weather and erode Earth's landforms. And that's just one example. There are so many others, like floods weathering valleys or glaciers eroding mountains. Let me break it down for you this way. See what I did there? The hydrosphere shapes and sometimes moves the geosphere. One last joke before I sign off. What did the geosphere say to the hydrosphere? You crack me up.
Elian, that was not okay. Okay, now using the information that we just learned from those 3 videos, we are going to click on this plastic assignment and you're going to open it up. You don't need to type or highlight. You're just going to click on the words and then drag it over, okay? So, I did not call on anybody. Elian, turn that off.
Living things.
Thank you. Okay, so on here you have instructions. Drag and drop each word from the table below, so you're going to have to scroll down, under the correct sphere. So there's 4 columns, okay? If you forget what each one means, it says hint. Geo means ground. Hydro means water. Bio means life. And atmos means air. Okay? So then you'll scroll down. And then there's 3 columns of words. Make sure you scroll all the way down. Okay? So the first one on the top left is mountains. So you're going to click on it, move it over, and then I'm going to think about, does mountains go with geo, hydro, bio, or atmos? Sophie? Which one?
Geo.
Geo. For ground? Good. So mountains goes here. Okay, I'm not going to click on it because this is the one that I made, not my student one. So then you'll scroll down. Now do the next one. Living things. Well, everything living would have to do with, Sophie?
Any living with bio.
Bio. So living things. Right there. Okay. Any questions? Elian Mastan. Sophie.
What do we do when we're done?
Okay. So make sure you have all of those words changed into each part. Dragged over to each part. Raise your hand and I will come check yours. Once I have checked yours, you can get your backpack and then go back to your seat and start cleaning up to go home, but you're not talking. And then once you're done cleaning up, ready to go home, you read your library book or go get a book from my library to read, and then we can do stamp charts when everybody's done. Okay.
I'm done.
Once you have that done, also click turn it in on Google Classroom.